Hello everyone, this is Xiang Gu from Peking University. It's my honor to present the paper Self-Illusion, a study on cognition of role-playing in immersive virtual environments. So, what happens when we role-play in a virtual environment? Research have proved that participants would experience several illusions. The first one, place illusion, PI, an illusion related to how the user perceives place. PI is generally used to indicate the illusion of being there. The second one, probability illusion, PSI. It's an illusion that what is apparently happening in the virtual environment is really happening. PSI provides correlations between external events and the user's own sensations. According to Slater's work, Pi and PSI are orthogonal and can both cause users physiological and psychological arousal, evoke a physiological response similar to the one that would occur in the corresponding physical world. Beyond that, however, is the question of whether there is a novel illusion when a user behaves in a virtual role that differs from the user's self in the physical world. In other words, do humans perceive themselves as themselves, or as their role in VEs? Here, we propose a new illusion, self-illusion, an illusion of self-concept. Self-illusion is a generalized illusion about oneself in cognition, eliciting a sense of being associated with a role in a virtual world, despite sure knowledge that this role is not the actual self in the real world. For example, when a user places a cat in a virtual environment, he may think he is a cat and interact with the VE according to the cat's behavior pattern, as illustrated in the left figure. Here are our main goals. Validate self-illusion's existence, measure it, and explore its effect on user experience in virtual environments. To make self-illusion emerge, there should be an obvious difference between a role's self-concept and a user's original self-concept. Also, users should be familiar with the role. Finally, we choose cats. There are two independent variables in our experiment: manipulation of probability (MOP) and manipulation of self-illusion (MOS). So there are a total of 4 different combinations, and that's 4 groups. Our dependent variables are participants' actual degree of probability illusion and self-illusion. We designed a questionnaire to measure the dependent variables. The questionnaire measures sense of embodiment, place illusion, probability illusion, and self-illusion in 9 items. The first 6 items were adopted from other questionnaires, and the last 3 items were designed by us. Here are the experiment procedures. Result: repeated measure ANOVA was adopted. For the effect of MOP, we should compare these two groups. The statistical result showed that they differ in items 3, 4, 5, and 6. These items focus on PI and PSI. For the effect of MOS, ANOVA showed that these two groups differ in items 7, 8, and 9. The results proved that our manipulation is effective, and the items we designed to measure self-illusion are reasonable. Also, self-illusion differs from PSI since they affect different items. We divided the behaviors recorded during participants' interaction with other cats into 5 categories. Categories A, B, and E are classified into incoherent response groups. because these actions are more consistent with the human's behavior pattern rather than cat's behavior pattern. In contrast, C and E are classified into coherent response groups. The chi-square test showed that participants with a higher self-illusion tend to act like cats in this stage. Overall, our research extends the scope of the illusion of cognition about the self by suggesting that there exists a higher level illusion about self-cognition than sense of embodiment, that is, self-illusion. This illusion is dissociated from place illusion and probability illusion. They affect the immersive VR experience in different aspects. Conclusion: we successfully validated the existence of self-illusion during immersive virtual reality experience. The higher the self-illusion is, the more commitment the user devotes to the role. Thank you for listening.